Get it while you can. I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, January 23rd.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights to the North Pacific Ocean, we see a swell front approaching the California coast generated by a previous gale, and then we see remnants of yet another gale pushing up into the northern Gulf of Alaska here, generating 26-foot seas. Swell has been generated by that and is radiating towards Hawaii and California as well. And then some other area of disturbed weather is over the dateline, not doing a whole lot at the moment. Let's get into the details. As usual, we start by looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet, just sort of like there. What that helps do is create a counterclockwise flow aloft and down at the ocean's surface. And in the northern hemisphere, a counterclockwise flow is associated with low pressure. Low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're big enough, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. So we have an area of interest right here. The jet stream is consolidated with winds 150 knots, pretty much going from Japan to a point north of Hawaii. Hawaii's right there underneath that. The split point in the jet, or the jet does split at 150 west right here, with the northern branch pushing up into Canada, southern branch over Baja. In between a split jet stream flow, you typically get high pressure, and that certainly has been the case in California. Nary a drop of precipitation, a little bit of wind, but most of it's offshore wind, and clear skies, and basically generally nice conditions. That'll hold for a little bit longer, but there is some thoughts that there is a change coming. All right, let's put this into motion. So we get into Monday, the jet continues to almost be consolidated, but right here, notice, almost looks like the jet wants to split because there isn't much wind energy in it. So we get into Tuesday. In fact, the jet does start to split. A little bit of trough here in the sets up in the northwestern Gulf, but not too impressive. And another one here just west of the dateline. So we get into Tuesday night. There we go. Better trough there and there, both supportive of gale development. The split point trying to hold for the minute. Wind energy builds into the jet as we get into Wednesday, feeding the trough here just off Kamchatka, and kind of a messy pattern develops where once there was a bulletproof high pressure system. Thursday, more of the same. In fact, winds actually build to 190 knots right over Japan, and the trough kind of washes out a little bit. As we get into Friday, more of the same. Another trough here off Kamchatka, and sort of a weak trough in the northwestern Gulf. Saturday, more of the same, another trough building off Kamchatka, and the focus really looks like it's in the far west Pacific as we get later and later into the model. And you almost get the sense that the split point here now wants to move to the dateline. It was here, 150 west? The last day of the model. It almost looks like it's back here somewhere. The dateline's right here, suggesting a pattern change. Also notice the jet forecast to push up into the Gulf, up into the Bering Sea, and then start falling south. Now, if you recall, back in the Christmas time frame, this was our exact copy of that same pattern, and back in October, same pattern. The point being, if this in fact happens, if the jet splits and all this plays out as forecast, that could open the door to precipitation and a change of patterns for California on down, most of the U.S. West Coast, and that would be the end of our high pressure ridge protecting us. It would also likely be the end of swell production in any meaningful fashion. All right, let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. There's a gale or a low or something, whatever you want to call it, over the eastern Aleutians, generating 40-knot winds, but all aimed up at the north at Alaska. Another little low here over the date line, 992 millibar low, barely generating 30-knot winds. Of no real interest. As we get into Tuesday, a new, we'll call it a storm. It has 50-knot, almost 55-knot winds in it. Develops west of the date line, building a little bit. 50-knot winds continue into the evening, and it lifts north over the northern date line region on Wednesday, and then just sort of spins out, and that's the end of that. Notice another little low up here north of Hawaii. Another little secondary low trying to develop underneath that, and maybe getting some traction as we get into Friday with a tiny area, 45-knot winds on the date line, sort of aimed at Hawaii, but not a particularly impressive system. That fades out on Saturday. We know the jet stream is going through significant changes at this period of time, so it's hard to say exactly what will or will not happen. Spurious low-pressure systems forecast, but do any of them get traction? And being a week out, is it even believable at all? Hard to say, but again, a change is suggested. All right, let's see the effect of those winds on the ocean surface. But we're going back about half a week to Tuesday night. A decent little system started developing west of the date line, started getting better organized as we got into Wednesday night. 30-foot seas building to 33 feet. And then a tiny area, 36-foot seas on the date line, aimed well at Hawaii. Continuing through the day, Thursday, still 37-foot seas on Thursday evening, and then it pushed east and out of the picture. Swell from this system has already hit Hawaii. Yesterday there were some pretty solid sets, both at Jaws and at Waimea Bay, probably. At Waimea, we'll say maybe 17-foot Hawaiian, something like that. Jaws, maybe more in the 14, 15-foot Hawaiian scale, something like that. Anyway, and that swell is pushing towards California as we speak. Another system developed Friday evening on the date line. Smaller, but still pretty decent seas. 36-foot seas right here. The highest seas over the entire image. Right there on the date line, aimed pretty well at Hawaii. Continuing through the day Saturday, seas up to 35 feet in the afternoon and then fading out. Swell from that is pushing towards Hawaii. And, and there we go for that. Let's go look at the forecast now. Starting right now, there's the image. Not a whole lot going on. We're sort of powered through this. Another gale forecast on the date line, lifting to the north date line region. So if the date line is right there, so it'll be up in here as we get, there we go, into Wednesday. Seas 35 feet. This morning's run of the model had seas to 39 feet, but now as we're getting closer, it sort of backs off. But still, some swell should result for both Hawaii and the U.S. West Coast. Nothing particularly impressive. And then this is where things kind of get weird. None of this was on the charts this morning. Now this afternoon, what are we looking at? 28 or 26-foot seas in the northwestern Gulf, maybe. That could get us some surf for maybe later in the weekend. Another system over the date line on Friday, generating 30-foot seas or so, aimed reasonably well at Hawaii and the U.S. West Coast. But they both fade out pretty quickly. And then who knows where we're going to be a week from now. But it looks like generally a fade away from larger systems and more small footprint systems, and pretty far away from the U.S. West Coast, focused more on Hawaii. Looking at winds, you can pretty much see where the jet stream splits. It's somewhere right here. The jet goes up like that and splits down like that. There's our low pressure system in the Gulf of Alaska, or the northwestern Gulf, lifting north, being pushed that way by the jet. Solid high pressure, though you don't see it on the chart, but upper level high pressure, just providing an impenetrable wall with light winds for the U.S. West Coast and trades for the Hawaiian Islands on, well, we can go back to Monday. I didn't look there, but yeah, trade, same thing on Monday. We'll go to Tuesday, pretty much the same deal. Another low pressure system tries to develop in the Gulf on Wednesday. Still trades for the Hawaiian Islands, very light winds for the California coast. Thursday, pretty much the same deal. Hawaii winds turn a little bit more southeast to this local low here. Then we get into Friday, still southeast light winds for the Hawaiian Islands, and maybe a little bit of a light south flow perhaps for California, but then that quickly just turns to more of the offshore flow. But you can see high pressure here, and then this kind of low pressure here, suggesting the ridging pattern that's been protecting California, certainly showing signs of weakening as we get into Sunday. Again, still pretty light winds, southerly winds starting to move into the Hawaiian Islands. And where are we? We are on Sunday night now, Sunday night, and a south flow for the Hawaiian Islands. Still California protected, but we know that isn't going to last for very long. Precipitation potential for California. In fact, let's go back here. You can see it quite clear. The blues here are the high pressure, the reds low pressure, the dividing line right there. Now we'll just plow through this because the reality is we're just looking for precipitation in California here, and you're not going to see any of it. It's all going to get shunted off to the northeast. This model only goes out 1 week. If it were to go a little bit, to right there, and there we are a week out. But you notice low pressure, a front trying to push down the coast, very weak. But if this model were to go out further, you would see a definite change coming. So this model goes out 10 days. You'll see it. This is the snow, one of our snow models. And we're really looking for something out here moving into the U.S. West Coast. We're into Wednesday, Thursday, Friday, Saturday. A little bit of precip in there for Vancouver and the Whistler area as we get into Saturday and Sunday. But then notice as we get into Monday and you approach the new month, February, right about then, that's where things change. And you see all of a sudden rain for Northern California, snow pushing down into the Sierra as we get into Wednesday, the 2nd of February, and maybe some decent snow approaching Tahoe on Wednesday, the 2nd of February. Now again, a model a week out, we don't believe. A model 10 days out, believe it even less. But we've been watching. There's some real long-range models we can tap into 2 weeks and a month out, and they've all been saying that starting somewhere around February 1st, February 3rd, the jet stream pattern changes again, looking more like what we had back in the Christmas time frame, and that suggests more precip on the way, a good thing for California. The downside on that is high pressure takes over the North Pacific, pretty much shuts down the swell machine. So you can't have both surf and snow at the same time. Apparently not this year, at least. Snow forecast dashboard for Squaw Valley. You actually see a little bit hanging out here on February 2nd. Actually, the earlier run of this model had like a foot of snow or something like that, so quite a bit of uncertainty still. You can also see things here. The freezing level at about 10,500 feet, pretty much stable, and then all of a sudden you hit February 1st, and boom, it drops down to maybe 3,500 feet, something like that. So again, the sense that a significant change in the pattern is coming. You have about a week and a little bit more to enjoy the nice weather, and then it's back to winter. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and La Nina or El Nino, the ENSO, El Nino Southern Oscillation. So we're looking for signs of the active phase of the MJO, the Madden-Julian Oscillation. There are two phases to it, active and inactive. The MJO is a weather pattern that rotates around the planet on the equator, moving from west to east. The active phase is on one side of the planet, the inactive phase is the other, and they rotate around each other. We're looking for the active phase moving over the Pacific, which is what we've had. And what that does, active phase is like low pressure, and it creates clouds. It actually dampens trades winds. It imparts energy to the jet stream, which then feeds the storm track and builds surf. It also can reverse trade winds or dampen trade winds as it pushes around the equator, and that in turn can take warm water that's in the West Pacific, start pushing it east under the equator in what's known as a Kelvin wave. Successive Kelvin waves, if they occur driven by successive active phases of the MJO, can help usher in El Nino. We don't see that happening, but there has been a solid active phase of the MJO, the first one in a very long time, and it has created a Kelvin wave. All right, so first off, we're looking at winds here. This chart, we're looking for signs of the active phase of the MJO. This chart shows winds. We're not looking at the colors, just the arrows here. And these are 5-day average winds. This is the East Pacific here. This is the West Pacific here. There's the equator. The date line's right there. Just look at the arrows. If they're long, that means strong east winds. So strong east winds in the East Pacific, strong east winds over the Central Pacific. Well, that's New Guinea there, date line there, right? So this is the West Pacific. We call it the Kelvin wave generation area. Because when the active phase is over here, and if it's strong enough and it reverses trade winds, that's when you get Kelvin waves. But winds look pretty strong out of the east at the moment. These are average winds, but what really matters is the anomalies, the difference from normal for this time of the year. So over here in the East Pacific, we're looking at the arrows again. They're not nearly as strong. Light easterly winds. Okay, well, that's still not great. Over the Central Pacific, light easterly winds, and light easterly winds over here in the Kelvin wave generation area. So no clear-cut signs of the active phase of the MJO. Looking at wind anomalies for the past 5 days, all right? We have 5 panels here. Whole planet on one chart. Let's get oriented. South America there, Chile, Peru, Central America, Hawaii, that little black blotch right there. The equator right here. Dateline 180 west right there. So there's New Guinea, Philippines. Kelvin wave generation area right here. The oranges are west anomalies. And again, Kelvin wave generation area is that area 5 degrees north and south of the equator from about 170 west out to about 135 east. So somewhere right around here. And yeah, generally westerly anomalies on the date line. This was on the 17th of January. Same thing on the 18th. Get the sense they're starting to fade out as we got into the 19th, 20th, and 21. So a slowly fading westerly wind anomaly pattern, probably suggestive of the demise of the active phase of the MJO. All right, let's look at the forecast for the next 5 days. This is a chart, all winds on the whole planet right here, just the east-west component of the winds, not the north-south. Okay, zonal wind anomalies, they call it. Westerly anomalies, which are the reds and yellows. Oh, let's get oriented first here. Sorry, date line right up the middle. There we go. And it's the West Pacific in the Kelvin wave generation area we're interested from 135 east, all the way up the chart here, to about 170 west right there. This is past performance up here, and you see pretty good amount of westerly anomalies from about Christmas into January. And then all of a sudden you start seeing easterly anomalies, this blue and westerly anomalies together. But then here's today, and here's the forecast, and you see the westerly anomalies just crashing, easterly anomalies taking over. If one were to eyeball this, I'd say this was probably the active phase of the MJO that we've been in. No surprise, there's been surf, thing, and this high pressure thing that's going on over California. It's an active phase of the MJO, but not a super strong one. One strong enough to affect the West Pacific, maybe getting into the Central Pacific here, but not strong enough to completely push the jet stream, consolidated the whole way into California. Okay, and it's a La Nina year, so that would be pretty much expected. And this is the first active phase we've had of any magnitude since July, something like that. So take what you can get. We've got surf coming from it, so that's a good thing. But it looks like that's all about to be over pretty soon. Let's look a little further out. All right, this goes out 2 weeks. Outgoing long wave radiation, OLR. Another word, fancy words for just cloud cover. If the MJO, the active phase, is a low pressure system, there's typically clouds associated with it. Conversely, the inactive phase of the MJO is like a high pressure system. High pressure typically doesn't generate clouds. So what this chart or this model does is try to show you where things are cloudier than normal or clearer than normal. The blues are cloudier than normal, the yellows, oranges, less cloudy than normal. The active phase of the MJO, the inactive phase of the MJO. All right, and this is a statistic model. Let's get oriented here. South America, Central America, Hawaii, New Guinea, equator right there, date line right there. So this would be maybe the weak late stages, the active phase of the MJO, and here's the inactive phase of the MJO setting up over the maritime continent. 5 days from now, active phase of the MJO. Oh, in the Kelvin Wave generation area. Well, it's right here to about 170 west, right on the equator, so right in there. You get 5 days from now, the active phase of the MJO almost out of the Kelvin Wave generation area as the inactive phase starts building over the maritime continent and pushing into the West Pacific 10 days from now, and then fully dominating the Kelvin Wave generation area 15 days from now, 2 weeks from now. So a transition from the active phase to an inactive pattern per the statistic model. The dynamic model, completely different, saying, yeah, active phase kind of falls apart, and then the active phase mysteriously reappears, rebuilds over the maritime continent, and then almost starts pushing into the West Pacific 2 weeks from now. So a little bit of a difference here. We see the two models. One says strong inactive phase 2 weeks from now. The other says whatever inactive phase there is, it's on the date line and fading already. So a little bit of ambiguity between the models here. All right, phase diagram. Same two models. Statistic model here, dynamic model here. This tracks where the MJO is exactly and how strong it is exactly. The MJO moves from west to east. How do we read this chart? Well, it moves from west to east from the Indian Ocean over the maritime continent to the West Pacific, to the East Pacific, over the Atlantic, over Africa, back to the Indian Ocean. The heavy dot, which is right there, is where the active phase is right now. And the further the dot is away from this circle, like out in here, the stronger it is. So if the active phase, it looks like it's in the West Pacific, it's very weak, and the forecast tracks have it moving somewhere into the Indian Ocean, and even weaker still. The dynamic model suggests pretty much the same thing, but the active phase getting stronger over the maritime continent, pretty almost the Indian Ocean, halfway in between the two, and far away from us, so of no particular interest. The upper level model, 8 panels here, 5 days each panel. South America there, Central America, Hawaii, right there, 0, that's the equator, dateline roughly there. There's New Guinea. Kelvin Wave generation area right here. So this, and the greens are areas favorable for precipitation. We'll call that the active phase of the MJO. Yellows, areas not favorable for precipitation. Dry air, the inactive phase. So right now, the active phase, somewhere over the Central Pacific, pushing south of California, February 7th. Maybe that also will help enhance that precipitation. Wherever this is, north and south of there, is the areas favorable for precipitation. Okay, and then comes the inactive phase, starting about February 7th and making its way across the Pacific as well. And then at the end of the model run here, March 4th, this goes out 40 days, the active phase trying to show up in the West Pacific again. So looking at this, I'd say somewhere between about the 1st of February to the 1st of March, probably not so much in terms, not much support for swell production, but perhaps better support for precip, at least in California. And then looking out 3 months. All right, this is the CFS model. Past performance is down here. The forecast is up here. Let's get oriented. The date line runs right up the middle here. Okay, the far edge of the Pacific Ocean, 135 east, right about here. So the Kelvin Wave generation area for the forecast is roughly in this area here. Now, the yellows, see it there, there. These are areas, these are westerly anomalies, again associated with the active phase of the MJO. Pretty strong active phase of the MJO happened here in January, around January 7th. Westerly wind burst, maybe that has generated a Kelvin wave. We'll find out here in a little bit. But you can see, starting today, looking forward, it looks like easterly anomalies, not particularly strong, but steady easterly anomalies into about March. and then all of a sudden the westerly anomaly pattern starts up again, suggestive of the active phase of the MJO. Let's overlay the MJO here. All right, not unexpectedly, so there the solid contour is the active phase of the MJO, but this is past performance. This is during December. The dotted contour is the inactive phase of the MJO. You see it starting to build, moving across the Kelvin Wave generation area, so it would not be surprising to see these easterly anomalies taking over for a while. And then this is interesting. The active phase of the MJO starts pushing into the far west Pacific even as we get into February, like February 2nd or 3rd, but it's like a 3-lobe active phase of the MJO, and it continues the whole way into almost mid-April. So sort of suggestive of maybe a shift of something going on. But you see westerly anomalies starting to build, easterly anomalies out of the picture as we get into middle of March, and then a light westerly wind pattern takes over. All right, let's overlay the low-pass filter. That will help make some more sense of this. The dotted contour here is the high-pressure bias, the La Nina indicator, if you will. And you notice it's smack right, it has been for the past 3 months, right over the date line, with, at one point here, 2 contours, but now only 1, and you see it slowly shifting off to the east. The line right now is almost to the date line, and as we get into March, it's on the date line or all east of there. The low pressure bias, which is the El Nino indicator, is over the maritime continent and has been, but you see it slowly working its way off to the west and building to 2 contours as we get into April. Again, that's 3 months out. Don't know if I believe it, but it sort of helps explain what's going on. High pressure, this sort of a general tendency towards high pressure that's been over the date line for 2 years now, La Nina, is slowly pushing east and fading, and a more normal low pressure bias, which normally is somewhere in the Pacific, is forecast to make its way back into its normal home base position. And that would be good, and dragging westerly anomalies with it. Now, the sad part is, by the time all this happens, winter's pretty much over. Once you're into late March, you can kind of forget about, this significantly feeding the jet stream and getting all these big winter storms. Probably isn't going to happen in terms of surf production. But at least it sets us up for the end of La Nina, or at least something that smells like the end of La Nina, and a return to a more normal pattern. All right, what's going on in the ocean, right? We've talked enough about the atmosphere, but El Nino is or La Nina is the coupling or decoupling of the ocean and the atmosphere. When you have cold water in the ocean, typically you get high pressure above it. That's prevents evaporation. You end up with this blocking high pressure pattern over the Pacific and lack of surf. Likewise, when you get warmer water in the Pacific, especially in the East Pacific, that starts feeding evaporation patterns. That feeds the jet stream, and you get more storms. All right, so we're looking at data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. This is the West Pacific here. This is the East Pacific here, only right on the equator, 2 degrees north and south of the equator. But we're going down into the ocean, down 100, 200, 300 meters. That'd be like 900 feet down. It's really, and we're looking for the balance of warm water. During La Nina, warm water is all balled up in the West Pacific and cold water's in the East Pacific. So right now, the 29-degree isotherm, that's 29 degrees centigrade, that's pretty warm water. It's actually, I think this is where it was last week, about 175 west, holding pretty good. 175 east. The 28-degree isotherm, about 176 east, not moving a whole lot. And the 24-degree isotherm at about 133 or something like that, 132 west, something like that. So warm water in the west, not so warm water in the east, pretty typical of La Nina. But it's not the actual water temperatures, it's the anomalies, differences from normal for this time of year. And here something really jumps out. You see this 3 degrees centigrade warm water, just like a river flowing from the West Pacific to the east, making it to about what is that point right there? I think that's about 130. Yep, 130 west, so almost a point south of California. This is a Kelvin wave. This is being generated by that westerly wind, the last active phase of the MJO that occurred in December, and the westerly wind burst there. It took this warm water here and is starting to push it off to the east, but not on the equator, under the equator, down 150 meters. So and cold water that was associated with La Nina, 2 degrees centigrade below normal, is getting steadily shallower, steadily less intense, and fading. The thought being this Kelvin wave is going to takes 3 months for a Kelvin wave to push across the Pacific. We think it's going to come right in, just obliterate this guy, and then start gurgling to the surface. That would be the ideal situation. Often what happens if the active phase that created the Kelvin wave isn't particularly strong, doesn't have particularly strong westerly wind anomalies, the Kelvin wave will make it somewhere over here. It'll stall and it'll sort of leach to the surface, but it doesn't have a big dramatic impact. From our perspective, any warm water over here would be great. It would just help sort of put the end to La Nina, and we need that for sure. Here's another model, same data, pretty much painting the same picture. Has the warm water making it to 130 is right about there. Yep. You see the cold water, pretty shallow, a little bit of warm water actually hanging over here off of Ecuador. You get the same sense of motion. This warm water pushing this way, and it's just going to come push up here and wipe the cold water out. Sea height anomalies. Another way, if you don't have sensors, I mean, you can't stick thermometers the whole way across the Pacific, right? But you can have satellites above the Earth, and you can measure the height of the sphere of the ocean, and that's what this is. Ocean height anomalies, not waves. So this actually is like Jason 3 satellite data. Strip out all the waves, strip out the wind waves, strip out the tides. Oh, and let's get ourselves oriented here. Chile, Peru, Central America, Hawaii right there, equator right there, dateline right there, Galapagos, that little thing there, New Guinea there. The yellows or reds, 10, 15, that's plus 15 centimeters. So the ocean's a little bit higher there. And over here, minus 10 centimeters, a little bit lower. Cold water contracts at depth, right? And we're talking, you know, not a little bit of cold water, but thousands of miles of cold water at depth contracts, creates a divot on the ocean surface. Likewise, warm water, thousands of miles of warm water, expands and creates a bump on the ocean surface. And then if you also have the trades nuking here, that takes any warm water here, pushes it off here to the West Pacific. So for almost the bulk of the winter, we've had negative anomalies over this entire region, but now notice 0 to 5 centimeter anomalies, making it to about 135 west. This suggests a Kelvin wave pushing to the east under the equator. And there were 15 centimeter anomalies here, and at one point 25 centimeter below normal anomalies here. We're down to a little patch at 10 centimeter anomalies, and it's just right on the equator. That's all that matters. Once you get further north than 5 north or 5 south, ignore all this stuff. That's not what's driving the atmosphere. They're more the results of storms and things like that. But right here, this is where all the action is. And what this suggests, again, that a Kelvin wave is in flight, and that cool anomalies in the East Pacific are getting less cool and have less of a stronghold on the East Equatorial Pacific. Then our favorite chart. This really helps put things in perspective. This is a time thing, time going down this axis here from a year ago, January 2021 to almost February of 2022. This is the West Pacific here. This is the East Pacific. This is ocean temperatures, not on the surface, but not down at depth. It's the whole column down 300 meters. You can see last winter, cold water, the blues here. This is La Nina. And then in February, we got a Kelvin wave. One here finally made it into Ecuador in about the April time frame. A second Kelvin wave in the May timeframe, a third Kelvin wave that stalled out in July. Then here was the second lobe of our La Nina. Cold water here actually larger in coverage than the year prior. But now notice Kelvin wave pushing across the Pacific steadily to about 135, maybe 133 west as of today, and looking to just wipe out the La Nina signature. And it's doing this in January. Last year in January, well, we really didn't get our first Kelvin wave going until about midway through February, and to get it over to 130, it was in mid-March, something like that. So we're about 2 months ahead of where we were last year. We think this is the end of La Nina, that some sort of a warm regime, not particularly warm, but at least warmer regime, is to set up. And you can see that here too. Upper ocean heat anomalies, just another way. This is for the whole region from 100 west to the date line. All right, but you can see back last spring and summer, warm temperatures building half to maybe 3/4 of a degree. And then as soon as we got into July, things bottomed out. But now you see, look at this. 1 pixel of warmer than normal temperatures here, suggesting at least a return to normal already. And we're not even done with January. Now, all that said, what's going on at the ocean surface? All right, let's orient ourselves. South America here, Chile, Peru, Ecuador right there, the Galapagos right there, Central America, Baja, Hawaii, the equator right there. It's sort of, the picture doesn't fit completely together, but you see colder than normal water from the Galapagos out to a point south of California. But once you get west of there, temperatures rapidly start warming. The extent of the cold water, not nearly as impressive as it was even a week ago, much less a month ago, but still a large area that goes down to 20 south or so, or more so. A little bit of warming here along Chile, but it seems that the cool pool, so this cold water, it's really coming from down in the ocean. We were looking at that cool pool, and it appears that the cool pool is fading at depth, getting squeezed to the surface by a Kelvin wave that's coming in from in this region. It's at, where is it, at 130 west, so it would be right along this line right here. As it pushes further to the east, it's squeezing cold water to the surface, so that's what we're seeing. But at some point, all the cold water is going to be going to be tapped out, pushed to the surface, and then you'll see nothing but warming in this area. Maybe. That's the thought. The trend for the past 7 days, and we're just interested right here in the equator. There's South America, Central America, Hawaii, New Guinea there. Where's the date line? Right there. The yellows and oranges, warming. So a general warming trend off of Peru and in pockets along the equator. Still some cooler pockets here too, but there was much more cooling here a couple of days ago and a week ago than there is now, suggesting again that deep cool pool under the eastern Pacific is maybe starting to tap out and on its last legs. And then finally, just the overview picture. Still, this is a clear La Nina signal. When you see colder than normal water, this is sea surface temperature anomalies. Differences from normal for this time of year. When you see this broad of a cool pool, that's a clear La Nina indicator. But also notice, a lot of warm temperatures over the entire rest of the planet. Okay, and we're not going to get into that discussion, but the suspicion is that this isn't going to last too long. All right, another way to look at it. The sea surface temperature trend in the Nino 1.2 region. This is the area right there along Ecuador and the Galapagos, and maybe down a little bit into Peru. Temperatures have been colder than normal, down at 1.5 degrees to almost 2 degrees below normal all fall and winter. We're slowly rising a little bit today. We're down 1.142 degrees centigrade, so it's colder than normal. The La Nina threshold's 0.5 degree. We've been below that for forever, so still cool, but warmer, probably the warmest we've been since we've gotten into winter, for sure. But that's sort of a noisy area. It's really the Nino 3.4 region. This is the area from south of California out to the date line on the equator. Temperatures there, pretty much stable. 0.861, 861 thousandths of a degree below normal. Again, the threshold is half a degree below normal for 5 consecutive three-month overlapping periods. So still clearly a La Nina signal and no immediate obvious change, but we suspect this is going to start creeping up based on all the other data that we're seeing. And the point being, once the ocean surface temperatures start warming, then the atmosphere above it will start changing. There'll be more evaporation, and then that sets some other things into motion. Now, the atmosphere isn't going to change overnight. We've been in La Nina for 2 years, but the thought is we're at least approaching a point where maybe things can start changing in the right direction. And so finally, what does the atmosphere think is going on? We've got all that cold water on the equator right in the main area, pretty much across the whole Pacific. So we look at the difference in pressure between Darwin, Australia, roughly in the Indian Ocean, and Tahiti, roughly in the Pacific. When pressure is lower in Tahiti, the index goes negative. When pressure is higher over Tahiti, La Nina, the index is positive. Today's value, plus 11.17. What's it been? Well, you can look at this. We were down minus 24, minus 27. This is all pretty good, even negative. We started negative about January. This is all pretty good signs here of the active phase of the MJO, though we suspect, based on all the data we're seeing, that that's probably at its end. The 30-day average, SOI, just takes the noise out of the daily ebb and flow of this. Today's value, plus 3.69. What's it been? Well, we got a high of, about 1307 right there in December. And now we've been on a steady fall, probably driven by the active phase of the MJO. We suspect this is going to start creeping up. Last year, this one at its peak got to plus 19. We haven't been anywhere near this. I think the highest we've been is 13. So La Nina not as strong as last year, but still it's there. The 90-day average, this really takes all the noise out of it, but it's also a 3-month lag. The value plus 7.56. Just eyeballing down through here, we were up to 10.9, and I think that was about it. That was the high for the year. Last year, we were at high of 15, and I think it happened in January. So not nearly as bad this year as last year, but still a little bit on the positive side. So all data indicates La Nina still in play, but in general, the atmosphere seems to think that it's not as strong and it's maybe losing its footing. Here's the 30-day index graphed out today. Was that about plus 5, something like that? You can see back in January 2020, we were very minimal, borderline El Nino, minus 5 roughly, and then we got into July 2020 and we were just on a skyrocket up. We got to plus 21 on this index a year ago. Then we fell in the summer, but then we were on a steady increasing trend to about plus 15 this year. Now we're back down. We'll see how high we get. I'd be really surprised if we get back to 15, even with the coming inactive phase of the MJO, because it's only going to last for maybe a month, and then there's another active phase forecast behind that. Then finally, the sea surface temperature forecast for the Nino 3.4 region, the official El Nino monitoring region. That region on the equator from south of California out to the date line. Temperatures today, what we say they were 0.8 or something like that below normal. That's about what this is suggesting, 0.8. The forecast says, well, maybe temperatures will dip back down as we get into April, something like that, and then creep up to about maybe 0.75 a degree, but not warming any more than that. I really wonder about this. In fact, we're going to look for a second here, but let's go look at the PDF corrected. It's still saying pretty much the same thing. Temperatures may be 0.7 of a degree below normal as we get into summer. Let's go look at one other bit of data. So that was data from one model. Here's data from all the potential El Nino, La Nina models, all the dynamic models, all the statistic models all over the planet. Then you take them all, average them together. This is the January update, and it pretty much has us returning to dead neutral in the June-July time frame. In fact, we can go down here and look. Here's every single model. I think this was the model we were just looking at, still showing those negative 3/4 of a degree temperatures. But all the other models far more optimistic. Here's the average of the dynamic models. It's showing a return to normal in the June, July, August time frame. Okay, the statistic models saying about the same thing. Average all those together, and we're at dead even as we get into, that's August right there. So theoretically, that one model we look at is painting a worst case scenario where all the other models say, it's not going to be that bad. That said, that CFS model, the CFS version 2 model right here, it tends to do a really good job. So we're going to keep our eye on it. I mean, we're going to approach the spring unpredictability barrier. I think that's towards the end of March, and the model struggles in there, and it's not till you pop out into like maybe the June time frame that this model at least gets a better handle on things. But for right now, we're going to take the doom and gloom predictions of the CFS with a grain of salt and say maybe a return to normal. I mean, that just seems more likely. So the good news for right now is swell is on the way for California. Even Southern California is going to get a taste of it from pretty west direction, so it should sneak through at least portions of the Channel Islands. Hawaii got their dose of it yesterday. Pretty good sized waves, as we said before. And it's not going to be anywhere near as big in California. It'll just be solid rideable surf, nothing more, with decent conditions. And then another pulse of a swell behind that as we get into Wednesday for California. I think for Hawaii that comes in on Monday. Again, smaller still, but rideable surf. And then after that, yet smaller surf. And then as you get about a week out, the jet stream probably going to unzip completely. We're going to get that big ridge setting up over the Pacific, and that sort of means the end of surf for a while, for a month, until the next active phase sets up. But even then, kind of wonder how much energy it's going to have since we're pretty late in the season. And, we'll see. That said, the good news is it looks like La Nina is losing its punch. Kelvin Wave in flight, going to push its way into the lower levels of the East Pacific in the next month or so, something like that. And that should pretty much, we're hoping, just be the end of La Nina. Whether we get to an El Nino, well, no models are saying that, but the thought is a return to ENSO normal, neutral, for next fall. That would be a great thing. Anything, just get rid of La Nina. Now, the problem is we've been in La Nina all winter. What's it going to do for our summer? Well, typically, I suspect that the storm production will be decreased this summer, and whatever we do get will be focused on the far southeast Pacific. That sort of takes, Tahiti out of the picture in some of those areas. It's not to say it won't happen, but typically during La Nina years, the focus tends to be more in the southeast Pacific than the southwest Pacific. All right, but as we get into next winter, hey, we'll be back in business, at least normal or neutral or something that more resembles just normalcy. If you enjoyed the video, there we go. Give us a thumbs up. We'd appreciate it. If you haven't subscribed, please subscribe. If not, links to the video are posted on every page at the top of the page of stormsurf.com. That's where all this data comes from. Follow along during the week. Check the charts. And then test your knowledge against this forecast. And yes, we will be doing the forecast next week at this time. Same place, same time. Go surfing. Have some fun. We'll see you then, and take care.